I'm excited too.
Thanks for
this
coming.
Is a topic close to my heart.
Oh, yay. Me too.
It's because his heart's a robot. This episode is sponsored by Component One, makers of Widgmo. If you need stunning UI elements or awesome graphs and charts, then go to widgmo.com and check them out. Hey everybody, and welcome to episode 103 of the JavaScript Jabber Show. This week on our panel we have Aaron Frost.
Hello.
Joe Eames.
Hey there.
Tim Caswell. Jameson Dance.
Hello, friends.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that is Raquel Vélez.
Hi!
Do you want to introduce yourself as the robot genius overlord?
I would not classify myself as a robot genius, but I am Raquel Vélez. I'm a senior dev at NPM Inc., and in my off time, I play with robots. I guess a little bit more background might be useful. I have a degree in mechanical engineering, and I built robots for about a decade or so. And recently, I left academia and robots and everything and decided to go onto the web, and then I discovered that you could actually do both at the same time, and that's what I do on the side.
Well, there goes all my spare time. You can do both, huh?
So I know NPM Inc. has been shipping a lot of merchandise, and have you built robots to help with that yet?
So no, not yet. You know, robots are kind of hard. They're a little complex. But I know that some people have been wanting their packages to come in more interestingly. So what we could do is we can package a package inside a package. And then we'll have a robot deliver that package via some package service to your door. And then you can open up your package, which will have the package that has been packaged, and then you can install it yourself. I don't know that would really help with latency, though.
That's really meta.
But it would earn you so much goodwill that you wouldn't have to worry about latency.
Well, you know, robots are slow.
You're going to contract to Amazon to build their drones, right?
No.
Delivery drones.
Did I say that quickly enough?
They may be slow, but I've seen them take down helicopters, or at least nodecopters.
Yes. Well, you know. The nodecopters. So nodebots and nodecopters have a little bit of a friendly rivalry. This year's JSConf should be no different, especially when we add node boats and node rockets to the mix. So
Yes!
Yeah.
Who's doing node rockets?
A team that I've not met yet. So this should be interesting. I don't know if they're gonna go really wild and have super explosive-y stuff, or if it's gonna be super calm and kid friendly. I don't know. We'll see.
Right.
So I wanted to ask about the journey from mechanical engineering, which is super low level, to running JavaScript as a robotics platform, which is really high level.
Yeah.
How did that start out? I mean, did you do software in your mechanical engineering degree, or did you have background in it before? Or how did you kind of make that journey?
So in the world of robots, right, there's a three-circle Venn diagram, right? You've got mechanical engineering, electrical engineering, and computer science. And then that kind of cross-section, that's robotics. And when I was in school, I was I definitely want to play with robots for as long as I possibly can, but electrons and I don't get along. And computer science just seemed really heady, it's really brainy, let's build compilers. I was I don't really care about that. And I saw mechanical engineering as arts and crafts, but with big machines.
That's so
and
cool.
That was super awesome to me. I was yes, let's do this. So I did mechanical engineering, but the fact of the matter was that engineering is cyclical, right? You can actually see it in the internet, right? For a long time, software was the big thing. And then because we were limited in our hardware. And so we tried to do as much as we could with software. And then eventually our hardware started to catch up. And then we ended up having these huge server farms and everything was hardware. And then now people are wow, now that we have all this hardware, we can do all this really cool stuff with software. And then so you just kind of see this cycle over and over again, cloud, blah, blah, blah. Same thing happens in robotics. You've got this world of mechanics and people are trying to figure out, well, how do we make this lighter and stronger and faster and gears, etc. But when I was in college, like the mechanical engineering part was mostly solved. It was like more of a situation where like if you wanted to work on the DARPA Grand Challenge, like autonomous vehicle robots, you know, you probably weren't going to be on the mechanical engineering team as a freshman, but you could totally join as like a software person. So I was like, I took AP computer science. I'll try the software thing. So I actually ended up doing a lot more software as a mechanical engineer. And then it was just like, okay, you know, mechanics are cool, but that's not really the problem right now. Right now, the problems are in AI and computer vision and planning and mapping and all that cool stuff. So I was like, okay, I will start like, so I basically I was like a software developer in robotics, even though I have a degree in mechanical engineering, if that makes any sense at all.
No, that makes a ton of sense. It was basically the easiest way to get into working with robots because the demand was higher for software.
Yeah,
Is that
exactly.
kind of summary?
Exactly. I mean, I was a freshman. I was like, I want to be on this team. And they were like, well, we have a spot open on the software team. So I was like, okay, cool. I'll do that. And like, it's just such an interesting problem. Like there's so many interesting problems to solve and they're all software based. We're now getting back into the realm of more mechanical stuff. Like now people are like building robots like nanobots using DNA, and that's like a mechanical problem. Yeah, okay, so anyway, that'll just blow your mind. Blows my mind
Star
all
Trek.
the time. Yeah, it's like really cool. Anyway.
Call me when I can run Node on DNA robots.
Yeah, I will. I'll let you know.
Yeah, we'll be invaded from San
Just
Francisco.
kidding.
We are Borg.
So basically what happened was I was in the robotics industry and I realized that the only way for me to really move up was to get a PhD and like write lots of papers and try to go on the academic track. But it wasn't really what I wanted, you know, like they're just, I remember studying for the GRE to go to grad school and just being like, this is dumb. I don't want to do this. And I was like, okay, so why don't I want to do this? And it was because I just wasn't passionate about it. So I, you know, meandered in different things. I ended up going to grad school for robotics and then I dropped out. I'm a grad school dropout. I'm proud of it. Yeah. And
That's high achieving underachieving right there.
it really is. Let's be honest.
I had 6 months left on my master's, and I just left for Node. So you know what? That's totally cool.
It's an elite club. You guys are part of an elite club.
I mean, yeah, basically. So then eventually I found my way into Node, basically because I was like, I'm bored and I want to have some fun. Who's doing fun stuff? And I found some people in my town at the time and they were like, we're doing Node. And I was like, okay, I'll do that too. And then I totally fell in love with it. And then I went to NodeConf Summer Camp 2012. So like that was back when there was like a NodeConf proper conference with speakers. And then there was the summer camp where it was basically just Node Core geeking out about Node Core, but I didn't know that. So I was like, I want to learn about the event loop. And I show up at this thing and they're like, domains, let's talk about domains. And I was just like, what is this? But I was there and I was talking to Chris Williams and somehow he found out that I did robots and he was like, you need to merge robotics and JavaScript and work with us on this. Cause he did Node Serial Port and then you've got Rick Waldron who does Johnny 5 and me being kind of more of the AI type, like having more of that background, I was like, oh, there's a niche here. Like you've got Node Serial Port, which is like super low, like hardware, like on the metal. And then you've got Fermata and you've got Johnny 5, which kind of like gives you that nice JavaScript, like jQuery like interface for programming your robots. And I was like, okay, I'm going to start with building some matrix modules. And then I kind of started bringing in some of the more interesting kinematics and higher level robotics theory to Node. And thus NodeBots has like become a thing. And then like, so from there, it was just like, oh, wow, you mean any JavaScript developer can start playing with robots? And then it just took off.
So I got to ask for some definitions.
Okay.
When you say matrices, do you just mean like the linear algebra matrix stuff?
Yes, exactly. So, yeah, not Keanu Reeves matrix. I meant like,
She's stopping bullets, Jameson.
I know Kung Fu.
Yeah.
I know Kung Fu. Yeah. So yeah, it was basically, So a lot of robotics is based in linear algebra. And that's not really something that we have very much of in Node Core and, well, JavaScript in general.
Not part of the web dev.
It's not. But I was like, well, could we do this with JavaScript? And it turns out that yes, we can, sort of. And I've kind of made a couple of intelligent, maybe not so intelligent. I've made a couple of cuts. I cut a couple of corners in the process of making Vector, VEKTOR, my matrix module. Mainly like the whole floating point issue that we have, kind of hand waving over it. It's like, it's okay. Which is why when people are like, hey, we should totally build autonomous vehicles with JavaScript, I'm like, no. I just sort of been like, no, it's a bad idea. At least not with my modules, which, I'm sure that at some point JavaScript can get to the point where floating point issues are not going to be as scary. But for now, we're kind of hand-waving past it.
So you also mentioned kinematics, and I do not know what that is.
Okay, so kinematics is basically, think of it as movement. So if you, let me use words that are accessible. And so if you think about it,
like this, you got to dumb it down for me. I'm fine.
Yeah, no, it's cool. Industrial robots, right? Like the robots that build cars and stuff.
Sure.
Those are the ones that basically are a bunch of cylinders attached with joints, right? And they have like a picker at the end, like a little end piece. So like you could even think about your arm as being a kinematic robot, right? It's just a serial manipulator is kind of the official term for it. But if you think about it, you just kind of like stretch your arm out and you think your shoulder is a joint, your bicep is a link that connects your shoulder joint to your elbow joint, right? And then you've got your forearm, which connects your elbow joint to your wrist joint. And then you've got your hand, which is your end effector. And the whole point of kinematics is the understanding of movement in your robot. So we have this notion called forward kinematics, which basically says, if I know the angles of each of my joints, where is my hand at the end of it? Right? So like, what's the location in space of my hand, given the different angles in my joints?
So that's probably just some trig stuff, right?
Exactly. And it's a lot of trig stuff. And it turns out that you can actually do it even faster and more interestingly with matrices and linear algebra.
Cool.
And then kind of the next level up is inverse kinematics, which says, if I put my hand somewhere in space, what are the angles of my joints in order to get my hand there? But if you think about it, like you could easily have more than one solution to that problem, right? Like your elbow,
sure.
You could move your elbow in a different position, but your hand would still be in the same spot. So like there's multiple solutions to inverse kinematic problems, whereas there's only a single solution for a forward kinematics problem. That makes any sense? Hopefully I've made that clear.
One more time. Forward kinematics is where you're moving from one position to another?
So forward kinematics is when you know the angles.
Oh, okay.
And you want to find the position.
Find the position. Okay.
Right.
And the other one is...
inverse is you have the position, you want to know the angles. So like, one way that somebody explained it was forward kinematics is you're using your arm, and inverse kinematics is you're using your legs, right? Like, cause you know where you want to put your foot when you're moving, but you don't know what angles you want your like knee and hip to be. But when you're holding your arm out, like if you want to like grab something, you know what your angles of, the angles of your shoulders and elbow are going to be, if that makes any sense.
No, yeah, that makes total sense.
Yeah, I think another way to put it is that forward kinematics is I know the angle so I can figure out where I am. Mm-hmm. And the inverse is I know where I want to be, and I need to figure out the angles to be there.
Exactly.
So there's probably like cost functions you can do with that, because it's probably more difficult to move in certain ways with a real robotic arm than others or something, right? So you're trying to like optimize the best solution for it, basically.
Yeah, exactly. Which
sounds hard.
It is. I mean, it's interesting though, right? I mean, like if you think about the robots that put together cars, right? Like you could just easily be like, okay, put the steering wheel on the steering column. Well, except that, you probably already have most of the car already built at that point. So you probably don't want to smash through the window. Especially
chops down from above.
What are you talking about?
Just maybe. So yeah, it's an interesting problem, and a lot of so that's kind of one of the angles that I've taken, no pun intended. And yeah, I love puns; they're so awesome. Yeah, so I'm going to be exploring some other options in terms of path planning and mapping and stuff like that. I've tried to hit those different topics in my various talks and stuff like that, just to kind of get people excited about the mathy part of robotics.
So I feel like I'm kind of in between, well, not close to your level, but sort of in between the person that knows nothing at all about hardware and electronics and someone like you who has a deep background in robotics. Mm-hmm. I played around with Arduino stuff. I've done a fair amount of just tinkering, but not with anything that moves, because that stuff all seems really hard. Mm-hmm. So how do I get started? Does that question make sense?
Yeah, absolutely. So give me a little bit more background. So far,
I can make the LEDs blink,
Mm-hmm.
I don't know. I can do stuff with pins on an Arduino. And
Perfect.
That's kind of the extent of my hardware experience.
Okay, awesome. So your mission, should you choose to accept it, and I think you will be to add a servo into your system. And the benefit of using a servo is A, servos are fairly cheap, and B, it's pretty easy to add that into your system without actually having to do very much effort, right? You put your power, so servos have red, white, and black, right? And so your red is going to be your power, and your black is going to be your ground, and then your white is your signal. And so you don't even have to worry about resistors or anything like that. Just plug those straight in using jumper cables, a breadboard, whatever you want to do. And then just kind of start playing around. You can use Johnny 5 to kind of start moving the servo up and down, and then start adding more servos. Start adding sticks to things. People think it's kind of ridiculous when we show up at NodeBots events and we have popsicle sticks and hot glue. That's what we have with us. We're here you go, popsicle sticks and hot glue. Oh, and here's a bunch of cardboard and some scissors. Have fun. And it's what is this? Arts and crafts time? It's yeah, it is. Because there's so much about building your robot out. And I think the best thing to do, and I say this to everybody, whether you're getting into web or getting into robotics, is to just come up with a project and start, just start playing around. Let's say you want to build a dog bot, right? So you'll have a chassis, right? That's your body. And then you need 4 legs. Right? And so what do you need for those 4 legs? Well, you can start off with 4 servos that just kind of go back and forth some limited number of degrees, and then see if you can program it to know, well, a dog, right? They move their front paw and their back paw, front right and back left, and then they move their front left and back right, and then see if you can get it to walk, right? And then you're oh, but this is really janky looking, robot. It's is skipping weird, and it's flopping around and looks really ugh. So you're okay, obviously dogs have more joints than just the shoulder joints or hip joints. So let's add more. And then you just kind of keep playing around with it and try to get it to balance and everything like that. It turns out that there are lots of mathematical equations for you to figure out, well, where's the center of mass and how do we make this work effectively and blah, 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 blah. But forget all of that and just start playing, because the math stuff helps to explain stuff, but it can also get in the way of you being creative and having fun. So I say go out, have fun, and then learn the math later if you really, really want to.
Aaron, you were going to say something?
No, she was talking about popsicle sticks and just silly little robots that are actually really cool to learn with. At NGConf, we did something with the guys who do Cylon, and we use pipe cleaners and Play-Doh, and it was we're making little robots with them, and it was actually really cool to see that you could play around with this stuff with a bloody pipe cleaner, and get feedback from a pipe cleaner. I was how do you possibly get output from a pipe cleaner? But you can, so it's really cool.
Yeah. Did you use conductive Play-Doh?
They brought it, the guys from, I can't remember their company, but they brought it also. I'm not sure what kind of Play-Doh it was.
Okay, cool. Yeah, because there's, if any of you have access to children,
I know where I can find a few of those.
Yeah.
I use trust kids.
Yeah, there's this stuff called squishy circuits, and it's really, really cool. You can basically have like multiple types of like you basically create this Play-Doh at home, and like one has sugar and the other one has salt. And I mean, it's totally kid safe and kid friendly, right? Like if they ate some, like it'll be fine. But what's really cool about them is that they're conductive, and so you can actually like pop some battery power in there, and then like start like connecting them together, and you can actually make some like really cool little circuits out of Play-Doh. And like, you know, I say access to kids because like 3 and 5 and 7-year-olds are like, whoa, this is so cool. But the truth is that like you start out, like you use them as an excuse, and then you play with it yourself, and then you have like way more fun. Because you're like, oh my god, I play with Play-Doh, and I can make the servo move using Play-Doh. And the person behind that, she actually helped teach me robots. She was one of my TAs in college. And like she makes sure that like you get a little bit more of that understanding of like electronic principles using all this stuff. And then, you know, you can kind of grow from there.
Is a servo just a fancy word for a motor?
So it's different from a motor. It's slightly different. So you've got like 3 types of motors, basically, in general. You've got like your basic motor, which all it does is you add some power to it and it just starts spinning, right? And there's no logic behind it. It just goes. Then you have a stepper motor, which basically keeps track of how many rotations you're going. And so you can do a little bit more like fine-tuned measurements. And then you've got a servo, which basically has like a little mechanism in there that tells you exactly how much it has rotated. Oh. So like you can basically put in an angle measurement and say like, you know, I want this to turn to 55 degrees, and it'll turn to 55 degrees and it'll stay there.
So I thought you had to keep track of all that yourself.
No, it's awesome. You don't.
Okay.
Yeah, it uses pulse width modulation, which is just a fancy way of saying it puts more juice in for bigger angles and less juice in for smaller angles. And so you say, I want it to go to 55 degrees, and it says, okay, well, 55 out of 180 is this much, so I'm going to put in this much juice, and then like blah, blah, blah. Like, and that's all done at like the hardware, like firmware level. And so you don't have to like, it's totally abstracted for you. You can just be like servo.move 45 and you're good.
So it's not actually a digital signal. It's just measuring the frequency of the flicker.
I think so. Yeah. Yeah. I mean, it depends on the servo, obviously, but I think the cheaper ones are just like more juice, more angle, less juice, less angle. You also have digital servos, you know, so.
So how much is a servo? Like you said, the prices are cheap, just to kind of give us people who are thinking about it. How much, what are the prices on them?
So like your super duper cheapo servo that you're going to get out of like the inventor's kit or something, you can get that for like $2 or $3. Now, granted, you get what you pay for, right? So if you're just starting out and just trying to figure out what's going on, I highly recommend getting a SparkFun inventor's kit or similar. I know Adafruit has something similar, and MakeShed has something. But basically, you'll get like a bunch of components in a box for like $100. That'll give you enough to just get started and have fun and play around. And you'll know in your head that like if you bust something, it's not going to be more than a couple of dollars to replace. As you get more familiar with how things work and how things are going and are willing to put in more money and invest, you could easily be paying. So like for the robot I had at JSConf, I think I paid like $12 per servo for that. And those are like good quality servos. If you have a chance to play Sumo Bots with us at a NodeBots event, those are like $15 servos. But if you see some of the stuff that like Rick Waldron's doing with like a biped robot, and he's got these like massive servos that can allow for more torque and more power, those can be like $30, $40, $50, $60, $100, depending on what you want. But to get started, it's really reasonably priced. Like, you know, $100 to play around with all sorts of different ideas is a really good buy, I think.
So one thing that I'm thinking about is at my kids' school, they have after-school programs that kids can do, and I think this would be really fun with the kids. I mean, you know, 1st through 6th grade. I have a daughter in 1st grade and a son in 2nd grade, and I'm just trying to figure out, okay, so this inventor's kit looks really nice. I'm just trying to decide what projects would work out well for them, like some ideas of some things that I can and have them do that they'll actually, look at and get excited about. Because I'm not convinced that they'll be excited about, oh, the light turned on, or oh, the servo turned, or whatever.
Yeah, absolutely. So you've got a couple options. The first one is what I call the bait and switch maneuver, which is you play with stuff and you get excited about turning on an LED and getting a servo to turn and coming up with little projects with popsicle sticks, etc. And then they show up and they're like, what is that? And you'd be like, oh, I don't know. You want to play? And then, then you kind of bait and switch. So that's one option. Word of warning, your kids are probably way more creative than you ever expect them to be. And they can probably handle a lot more of stuff than you probably ever expected. But you already knew this because they're your kids, and I'm not saying anything new. So they are, like, they'll just run with it. They'll be like, oh my God, let's make a giraffe, and like, just like start, like, you'll have one kid who's going to be like all mechanically, and they're going to like start building this whole popsicle monstrosity. And the other kid's going to sit there and be like, okay, how do we hook this all up together? And blah, 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 blah. And that'd be super cool. So that's option one. Option two is if there's something that you know that they already like, maybe one of your kids really likes Legos, maybe, one of your kids really likes animals or whatever. I don't know your kids.
No, you picked both of my kids. My son loves Legos and my daughter loves animals. So
okay, so what you could do is there is a kit called the Lego Mindstorms. I don't know if you've heard about this, but it's about, this one's a little bit more pricey, right? It's like $300.
They're totally cool, though.
I have been eyeing those for a year or so now.
We do a huge event with them every year. They're lots of fun.
Because I want to play with them. I mean, I want to get them for my kids. That's what I meant.
No, of course, of course. Fun factoid. Back in, I want to say 2005-ish, I remember like the first time I played with Lego Mindstorms, and I read somewhere that the average user of the Lego Mindstorms kit was a 35-year-old man. I was just like,
that does not shock me.
That is really funny. So yeah, like get the kit, and just like what's nice about the Lego Mindstorms kit is that not only is it Lego, so it's really easy to play around with, but it's also like they have a whole bunch of like preset things that you can do with it. You can kind of play around, and they have their own motors, and they have different sensors and things that you can play with. And you can choose if you want to use their kind of weird programming language that is really visual. It's like blocks. You drop blocks together, and it's
the Google's App Inventor. If anyone ever used that,
right? Or LabVIEW,
LabVIEW. Yeah,
it's just like LabVIEW. Or you can actually flash the firmware on the Lego brick, and you can use C or JavaScript or like all sorts of things. I don't know if you can use Node yet. I know that I want to say Andrew Nesbitt in the UK has created a flashed like option for Lego Mindstorms. Somebody did. I know that he tweeted about it once. But yeah, so I know that you can probably use JavaScript on the Lego Mindstorms as well if you want to just kind of stick with that. Or if you want to do other stuff, that's also a perfectly valid option. I personally, my first robotics competition I ever did was with the Lego Mindstorms, and I did it using Robot C, which is like a really simple version of C. And I did pretty well in my little robotics competition. So that holds a near and dear place in my heart. But yes.
So we've talked a lot about all the different hardware and kits and options and stuff. Mm-hmm. I want to kind of bring it back towards JavaScript and ask what is unique about doing this in JavaScript. Is it just because the community is very large and excited, or is there something unique to the language, or I don't know, is it like right place, right time, or what do you think?
Yeah. So I have opinions. I think
I want to hear them.
Yeah. So traditional robotics has kind of always been in like C++ and Python. Like if you go online and you look at the job description for a Google roboticist, it says, you need a PhD and, well, preferably a PhD and at least 5 years of robotics experience, knowledge of Unix and C++ and or Python and blah, 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 blah. Snooze alert. Also, wow, that's a lot of effort and time to put into this stuff before you get to work on these like really cool robots. My personal opinion is that you shouldn't have any barriers to being a roboticist. You should just be allowed to build a robot using whatever you want. So for that reason, I think JavaScript is an amazing language because so many people use JavaScript at this point. Like there are so many different like polls out there that say like what language is most popular right now. And all of them say that JavaScript is in the top 5, right? If not the number 1, it's like the top 5, just in terms of like use, like overall global use. Like if you're on the web, you've probably touched JavaScript, even if it's in the form of jQuery. So the fact that it's so easy and it's so broad, like out there, like it means that you can just kind of get started. I was watching this talk at Cascadia.js, and it was like this 15-year-old kid. It was awesome. And he talked about like why he decided to learn JavaScript. And it was because you didn't have to set anything up on your computer. You could literally just go to your browser, go into the inspector window, and start programming in JavaScript. You know, like var A equals a string, hello world, console.log A. Like boom, done. Like you didn't have to set anything up on your computer. You just needed to have a browser. So in that sense, JavaScript's usability is just incredible and widespread. And if you're already programming JavaScript, why should you ever be limited in playing with robots? You shouldn't. The other thing is that in the world of robotics, there's a lot of unsolved problems, right? It's hard. It's really difficult in terms of just understanding, well, how do we make the world, the mechanical world, the computer world think in a similar way to our human world? And the perfect example is this idea called sensor fusion. So if you're a human, right, you have multiple sensors. You've got your eyes, you've got your ears, you've got your nose, you've got your mouth, head, shoulders, knees, and toes. No, those aren't sensors. But you have all these sensors too, and somehow, magically, your brain takes all of these inputs and says, okay, I understand where I am and what I'm doing, and I can now make a decision about what I want to do next and where I'm going to go next, right? Robots, if you think about how you're going to do that, that's way more complicated a problem, right? Now you need some sort of vision option, which will be probably like cameras or something, right? But then you need depth as well. So you have to either have more cameras so you can have depth perception, or you need like a lidar, like some sort of radar sort of thing to kind of say, this is how far things are from me. And then for touch, you need like bumpers. For sonar, like, if you want to hear things, like now you need a microphone. Like you've got all of these different things. And then the question of how to fuse that input, all those inputs together is really hard, right? So how do you do that? And if you think about it in like a C++ type of environment, you're using threads, right? You've got a threaded system. So each thread has its own proprietary sensor, or each sensor has its own proprietary thread. And then you have some machine in the background that's saying, okay, cameras, I have information from you, depth information, I've got it from you, microphone, blah, 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 blah. But then how do you make sure that it's all time synced? How do you make sure, like, what if you have latency? What if you have noise? What if you have, so it's a really difficult problem. On top of that, you're using all these threads. So I always think about this whole notion of what if you try to attack the problem in a completely different way, right? Like you see a brick wall and you're like, I need to get onto the other side. Do you climb over it? Do you try to smash a hole through it? Do you try to climb under it? Or do you just look to the left and realize that it ends and just kind of go around it, right? Like there are so many different ways of attacking the same problem. But if you're so embedded in this threaded ecosystem, what might you miss if you were to suddenly turn around and try to use an asynchronous ecosystem? Like what would that mean? What could that mean? I don't know the answer, but from a researcher, scientist type of point of view, like we got to try. So I am kind of opinionated on this, and I know, but I think that if we give JavaScript developers the opportunity to tackle this problem, we might be really surprised by what they come up with. And like this is the same reason why I push so hard to get people of all different backgrounds and everything to try the stuff that we're doing all the time, because the different perspective and the different knowledge that people have could just surprise us in ways that we never imagined. And who knows, maybe JavaScript is the solution to a sensor fusion problem. I don't know.
Huh. I'm just thinking about all that stuff. Oh, sorry, go ahead, Tim.
I was just going to say, talking back to accessibility and getting kids into it, the thing that I had fun with last summer was getting a Chrome app or a Chromebook to talk Fermata directly.
Mm-hmm.
And the proof of concept actually got working by the end of the hack day. And you can take an off-the-wall Chromebook from Walmart, plug in an Arduino that has been flashed with Fermata, and just download this app, and you can talk to it. Like, you don't have to install this thing. You don't have to download Java or whatever these dependencies are. And what other language has that kind of accessibility than JavaScript?
I don't know. Right, exactly. Exactly. I mean, it's amazing how you could just so quickly get involved and just start tinkering. JavaScript is easily my favorite prototyping language. You know, anything I want to do, I start with JavaScript, and then if I need something else, then I'll go to something else. But so far, in the last couple of years, I haven't needed anything but JavaScript to do anything that I want, which I think is kind of awesome.
One of the issues I had using Node for these kind of background robotic things is it uses a relatively large amount of RAM on these little devices. Like, I have this TP-Link router that I got from China, and they use them as robot brains. They stick sensors to them and do weird things like locking doors or who knows what. But these devices have 8 to 16 megabytes of RAM. And a stock Node process is like 12 megs. And you still need room for the OS. And so I've been trying over the past years to find ways to reduce the JavaScript footprint, but still have this nice high-level scripting environment. And it's a fun area to explore.
Yeah, absolutely. Part of me is just like, wait a year or two. You'll get more space. Like, whatever, the hardware situation will just, But that's obviously not that's the lazy approach, right? That's the, if you just wait a little while, you'll get more space for just as little money. But yeah, no, it's definitely an interesting question. I don't know. So the question is then, do we go the Tesla approach and have a not quite JavaScript option, right? That converts to Lua? Or do you go with the variety of other options that are currently out there, like JavaScript on hardware? It's an interesting problem. So far, I haven't seen a full JavaScript, totally 100% legit ECMAScript, option on hardware. Nobody's done that yet. It's always been, we're going to kind of do JavaScript-like. So.
What do you mean on hardware?
Did you say Tesla?
Tesla, yeah, Tesla IO. So
those are the boards that just you can run JavaScript straight on them, right?
Yeah, exactly. And
those
there's another
crazy.
one. Yeah, there's another one, and I totally forgot the name right now. But this is a thing. People are like, well, JavaScript is a thing, and hardware is a thing, so let's marry the two together, right? And let's see how that goes. And some very successful stuff so far. But the JavaScript enthusiasts who are really oh my god, JavaScript is my religion, they don't like it so much because it's not real JavaScript, quote unquote. But then you have the other people who are like, oh, this isn't real hardware because it has JavaScript on it. Why would you dirty it? So there's haters everywhere. No, you can't win. But the people who are like, all I want to do is I want to use this language that I know to turn the lights on and off in my house from far away. This is perfect. This is everything I want it to be. So, I don't know. I just say, everybody, whatever. Go have fun. Just have fun. I don't care. Stop arguing.
Fun.
Go have fun.
So, AJ actually just posted in our chat here a link to Tesla.io.
Mm-hmm.
I guess it's a new microcontroller that's coming out this spring.
Mm-hmm.
And it's claiming, it says Tesla's a microcontroller that runs JavaScript. It's Node compatible. You can, sorry, you guys were just talking about that.
It's all good though. No, Tesla it's promising. It's interesting. And, there's a lot to be said for it, and it could be, I don't know, it could be exciting.
So have you seen the duct tape VM?
I haven't.
It looks to be a pretty fully implemented JavaScript implementation as a very minimal VM, basically how Lua is written. It's a very similar CAPI and architecture. So you get a lot of the memory footprint of Lua, but with real JavaScript.
That's awesome.
So that sounds very interesting. When I get some time, I'm gonna see about binding that to libuv and make a Node Lite or something.
Nice. Do it. Go forth.
So how good is Johnny 5 though?
So
what do you mean? How good is it?
Define good.
Easy usable as a starting point.
Let me lay it out for you, Joe. I can do stuff with Johnny 5.
Oh wow.
So that's how easy it is to use.
Johnny 5 is jQuery for
My cat could
for
probably
Mata.
do stuff with it then.
Oh, probably. It is, if you know jQuery, you can handle, like, if you've only played with jQuery, if you understand the general syntax of jQuery, you can do Johnny 5. Like, it's literally as easy as declaring your servo variable that is, you use the servo constructor, and then you say, like, so var servo gets servo constructor, that's it. And then you can basically say servo.move, and you put in, like, a number. Or, like, if you want an LED, you say var LED gets the LED constructor on pin 13, and then you say LED.on, LED.off, LED.strobe. Like, there are so many options you can do. It's really easy. It's really, really easy.
So at the end of this episode, we're going to have like 1,000 people that are going to say, I want to go play around with robotics and JavaScript. What do you think is the way that they should go then? Johnny 5? And
I think so. I'm partial to Johnny 5, probably because I'm really good friends with Rick, but it's just so easy. There are other options, right? Like there's Cylon.js, which is it's a different implementation. It attacks the problem differently, but I really like the jQuery-like sort of thing. Just because so many of us probably got our start with jQuery, and it just flows. It just feels really natural. And you don't need much, right? You get an Arduino for $20 and set of stuff. I mean, like literally $100 to just kind of get started, have fun. Yeah, or just come to a NodeBots event. Like, these events are happening all over the world, literally all over the world. We've had events in Australia and Colombia and the UK, and then in so many different cities around the US. If you're in the Bay Area, we do one once a month, and so that's super fun. I know in New York they're doing them pretty regularly as well. So if you don't want to even spend any money at all, just show up to one of these events and just like be like, all right, Rockbot told me you would have an Arduino for me to play with. May I please have an Arduino? And then be like, oh, well, if Rockbot said, then fine. Yeah, go ahead. Use my name. It's fine.
And then drop. Can we get you to give us some links to recommend hardware that you would recommend, like starter kits, Arduino starter kits you would think are good?
Absolutely. I'd be happy to do that. I'll do that.
We put those in the show notes.
Yeah.
So, you've mentioned the NodeBot events. I'm sure we'll have a link to those too. Mm-hmm. How else do you find kind of a community? Is there like a secret cabal that meets on IRC that you can like sneak into? Or I know that, like the maker scene is kind of related to this stuff too.
Absolutely. Okay, so there's a huge community of people out there just in terms of making stuff, right? So you can always go to like your local hackerspace, and they'll introduce you to Arduinos pretty easily as well. But they might not do JavaScript Arduinos, right? So keep that in mind. But, whatever. On IRC, there's the room #robot.js. It's been pretty quiet lately, so if people started showing up and chatting, I would chat too. So, haha, now everybody has homework. So there's that. And then, but otherwise, a lot of stuff happens in the Johnny 5 repo, like people are constantly putting like issues, etc. It's a pretty strong open source project, I think. And then just at there's so many different conferences that are having NodeBots events now. Like JSConf last year was the first one to have a NodeBots dedicated event within the conference. And that was a full day thing. We just had pretty much every component under the sun, and you could just build whatever you wanted. And then that grew, like we had events at NodeConf, and then we had International NodeBots Day, and people are doing those all over the place, like I said. And then there was RobotsConf, which was a pretty big conference last year. That it was basically, we took the middle day of JSConf last year, that was like NodeBots for a day, and we turned it into any type of bots for 3 days or 2 days. It was a 2-day event. And so that one was language agnostic. If you wanted to do Node bots or Ruby bots or Python bots or whatever.
I was curious what language kind of like championed there though. Was it?
I was there and I feel like it was JavaScript, but maybe that's just because that's what I used.
Yeah, I saw like everybody had those like, when you go to a bar or something, like they give you that wristband, that like plasticky wristband. We had different colors for your language. And like, it was just a rainbow of colors. Like, there were people who did C and C++, like C flavored stuff and Python stuff. And
there are a bunch of Ruby people too, yeah.
Yeah, there's a ton of Ruby people. There's like a few people who were like, I don't do web. I don't do web, but I'm going to be here and play with robots anyway. And it was really cool. Super, super cool. So yeah, there's a huge community of people out there. If you're not specific about JavaScript, you can find an even bigger community, right? There are Maker Faire events all over the place. Definitely go seek out your local hackerspace. If you don't have one, start one, or find a bunch of kids. There's so many opportunities for getting involved in the community. But definitely, if you want to do specific NodeBot type stuff, definitely recommend a NodeBot event. And nodebots.io, we definitely have information on how to start a NodeBots event in your community. I think we're going to try to do another International NodeBots Day, which is basically all the NodeBots groups in the world on a single specific day have their event, and then we can all Skype or Google Hangout at each other and be like, "Look at my robot! It's so cool!" It's pretty fun.
That's awesome.
It's pretty fun.
I'm excited. I'm excited to go play with this stuff.
I would like to ask if you've played around with Sphero and using Cylon.js for it.
So I have seen a bunch of Spheros. They're super cool and fun, and they light up and they're bright and stuff. I have not actually programmed them yet at all, but I have seen people using Cylon, and I have seen people using kind of a Node, Johnny 5-ish. There's a Node Sphero module that you can use. The big issue with Spheros is that if you have too many in the same space, because they're Bluetooth enabled, there can be a little bit of difficulty. But if it's just you and yourself, hanging out at home, it's totally cool. A really cool game, by the way, with Spheros is to get a bunch of planks of wood or sticks or something, and have if you want to get kids involved, have them kind of program the Sphero to solve a maze using the sticks. That's a really fun game that is interesting but simple, a really simple setup. All you need is a Sphero and a bunch of sticks, but then it will provide hours, days, weeks, months of entertainment depending on how far you want to make it go and stuff like that. So that's a pretty exciting thing too.
I was going to recommend that on another robot to for people to get introed into node botting. Sphero's a cool little robot. They're super non-intimidating because it's just a friggin' ball. So you don't have to worry about a million moving parts.
Yeah.
And at NGConf, that was our only hack night, was a hardware hack night. And we had the hybrid group brought 60 of the Spheros. And there was a little bit of the Bluetooth thing that you're talking about.
Yeah.
Our funnest app, I think, was a tug of war. Half the room would tweet the word blue, and half the room would tweet the word red, and it would kind of tug of war back and forth. But yeah, it's another cool little non-intimidating robot to kind of get started with.
Yeah.
Which Bluetooth is that? Is that the older one or the new low energy?
I think that most of the ones that we had there were the Sphero 1.0, so they had an older Bluetooth. But the new ones have the Bluetooth LE, so...
Yeah, I think that doesn't conflict as bad. I'm not sure. At least I hope.
I've had people ask me about a Raspberry Pi versus an Arduino as far as ease of getting started. And my stock answer is that Arduinos are a lot easier to get started with if you're just manipulating some pins, basically. Mm-hmm. Do you have an opinion on the Arduino versus Raspberry Pi thing?
I do. I think the benefit of the Raspberry Pi is that it's a computer, right?
Mm-hmm.
It's a full-on computer. The Arduino is just a microcontroller. So I think that in terms of just getting started, plugging in a USB, plugging in an LED, your best bet is an Arduino. But if you want to do more complicated things, like having a wireless system that, so one thing my husband and I want to do is we want to have a button, a music button, so that when we get into the house, we can just hit a big red button and then have music start playing in our house. That'd be super fun, cool. Right? And we're well, we can't really do that with an Arduino because then we're going to have cabling and all of this stuff. Whereas if we just had this low, passive sort of thing, button, if we had multiple buttons around the house, then we could just hit one button and then have it send a signal to, say, a Raspberry Pi, then it would be able to it's a computer all on its own. We don't have to have something extra. One of the downsides of playing with an Arduino is that, especially with Johnny 5 and stuff, if you want it to do anything interesting, all the computing is done on your home laptop or on your regular computer, right? And then like the Arduino only takes the commands. And so like I've cut the cord by using XBs, which are like little radios that, so like instead of using a USB cable, you can use XB to kind of have over the air communication to say like, if I'm using a Bluetooth PS3 controller, then I can like, move a robot around with just my controller, but it's not the Bluetooth controller talking to the Arduino. It's the Bluetooth controller talking to the computer, and then the computer sending commands to the Arduino. Whereas with a Raspberry Pi, you would basically take out the computer because it is a computer, right? So then you could actually have, if you had like a Bluetooth enabled piece, then you could like have the Bluetooth actually controlling the robot itself.
Sure.
So yeah, it really depends on what your project is and what you want to get out of it.
Now I just want to ask you what other cool ideas you have for stuff to do to your house. We're about to move into a new house, and it'll be the first time I can like rip stuff out of the walls.
Well, I think it's interesting you're talking about this, but a lot of the things that you're talking about have been handled by a lot of the home automation stuff. So a lot of them have motion sensors and light sensors, and you can actually not only turn on and off your lights in a room, but they'll detect that somebody walked past or is in the room, and then can turn around and automate a lot of that stuff too through your Wi-Fi.
Yeah.
So,
but it's so much cooler to make it yourself.
That's what I'm wondering is where's the line between home automation and robotics, like what we're talking about here.
So the line is the same as home improvement, right? So if you are willing to build your own table, then you should build your own table. Similarly, if you're willing to build your own, music starter upper button, then you should do that. If you are not willing to tear up your entire kitchen and make your entire kitchen from scratch using everything that you can find at your local home improvement store, then you probably should not go in and take out all the wiring in your house and redo everything so that you can have motion detectors, etc. Like, scope is important, cost is important, and amount of time that you're willing to spend on something is also important. So my personal line is, if I can work on something on the side and it doesn't affect my day-to-day life, and then it just adds something fun at the end of the day, then I'm totally going to do it, because even if I don't finish that project, it doesn't mean that I don't have a kitchen, right? Like I don't have a stove or something. Like, I need my kitchen. I don't necessarily need the music button, though it would be really awesome if I did. And then, of course, is also just how much do you end up learning about electronics and home automation and et cetera from building this one, music button. Like, there's so many options, learning a new API, et cetera. That's it.
Cool. Are there any other things that we should talk about here before
I want it to last forever, but
well, you can always tweet at me. I'm actually like really good at responding to tweets on Twitter and terrible about responding to emails. I don't know what that says about me, but yeah, so anytime you want to chat, like, by all means, tweet at me, we'll chat, I'll share my crazy ideas. Come on to Robot.js IRC, and we'll make our employers think that we're typing very furiously on our projects. Although, let's be honest, I really have a lot of work to do.
Yeah, you're in a startup. I think they'll feel it if you back out.
Oh yeah. There's so many things I've got to do on my list. So.
All right. Well, let's go ahead and get into the picks. Aaron, do you want to start us with picks?
Yeah. So just kind of thinking ahead to next week when this episode will go out. I'm going to pick, I have like 80,000 picks. So a lot of people, like the Jamesons, they love NodeConf and RobotsConf. But there's a lot of people who, like, they have one conference a year they want to go to, and that's Google I/O. And about 80,000 people are going to get an email next week saying that they didn't get accepted to go. And they're going to get that the day after we release the podcast. So I'm just going to pick all 80,000 of them and tell them that we love them. Aww. And don't be sad. There's always next year. That's my pick.
All right. Tim, what are your picks?
I picked DuckTape.js that I mentioned earlier because I think it's awesome. Someone made a minimal JavaScript runtime that seems fairly complete, and I've been wanting that for years. I just never had the time to do it myself. So, yeah, that's my pick.
Jameson, what are your picks?
I have 3 picks. One is a music pick that I thought I have picked before, but I haven't. It's this band called Frog Pocket. They do really glitchy electronic music. The buzzword is IDM. I'll post a link on YouTube to one of their songs, and if you don't like this song, then you'll probably really hate them. But if you like this song, then you'll really like them. My next pick is Homestar Runner, because holy crap, they just updated their website after like 5 years, and it's so good. Oh man, Homestar Runner is a big part of my youth, and it's awesome to see them adding more stuff. And my other pick is a game called Towerfall. We have a PlayStation 4 at work, and this is literally the only thing we've ever used it for. It's this like $10 indie game that you can download. It's kind of like Super Mario mixed with Super Smash Brothers. It's just a blast for local 4-player multiplayer.
What's it called?
Towerfall. They have it on PC and on Ouya and on the PlayStation Store too. I don't think it's on Xbox, and it has to be local. You can't play online just because it's so twitchy and fast and stuff. But if you have one of those platforms, you should totally play it. And those are my picks.
All right, Joe, what are your picks?
My first pick is going to be the PC game Titanfall. I picked that up a week and a half ago and have been playing it. And of course, I can't imagine anybody who hasn't heard of Titanfall because it was such a hugely advertised game. But it's actually been really fun. I picked it up on the PC because I think that shooters on a console are retarded. And and I do enjoy it. It's not like, I think there are better shooters out there, but it is really quite fun. My second pick is going to be SaltCon, and this is my final pick as well. SaltCon is a 3-day conference held somewhere in the Salt Lake City area every year, and it's just 3 days of playing board games. It's not like an expo where you go and just go to booths. It's just tables set up and board games you can go grab and play and meet new people and play board games. And similar type games as well, dice games and role-playing games, but primarily board games. And I got to see a bunch of really cool games that are going to be coming out in the next few months, either the ones that got kickstarted or something, and maybe I'll pick those in future episodes.
Very cool. All right, I'm going to pick a couple of things that I've been using lately. One of them is Diablo 3. I've been playing that off and on. It's just a nice little escape it takes me anywhere from a half hour to 45 minutes to complete a series of quests, so to speak, to get one major thing done, I guess. So that's just enough time for me to kind of relax and then go back headfirst into work. Another one that I'm going to pick is Flowdoc, flowdoc.com. It's a chat room for teams. The cool thing about it is that you can set up multiple rooms or flows or whatever they call them. And then within each one, you can actually have different contexts. So if you type something in, then somebody else can actually pick up the thread and reply to just that thread, comment on it. And that's really convenient if you're having a conversation with somebody and, you don't want the whole mess of stuff that comes through in things like an IRC channel. You get that too. You kind of get the fire hose and then you get the filtered hose on the other side. And you can also set up notifications in it and things like that. Really, really handy. And I have also, I've been using their desktop app on my Mac, and it seems to work all right. So those are my picks. Raquel, what are your picks?
Okay, so I am a huge, huge fan of the Pastry Box project. That's the Pastry Box project with hyphens.net. I am a little biased because I write for them this year, but the thing I love about it is it's just a beautiful daily look at the way people think, especially in our industry, because it's not really very technical, but not always. Sometimes it is. But there's just some really cool perspectives and stuff that are in there, and I think it's good for the brain. My next one is cuteoverload.com, because we all need cute things in our life, especially when there are moments where you're just like, I hate trolls and I hate the world, but oh look, it's a really cute bunny. And then it's springtime in the Northern Hemisphere, and I think that is a good excuse for people to go to their local parks and to explore the outside world. I know that as developers, we have a tendency to kind of stay inside a lot and not get as much sun as we need because, work or something. But there's probably a tree in your neighborhood. Go and just look at it. Just go outside and do
Raquel,
something nice.
You're in San Francisco, right?
Yes.
Let me tell you a little something about Utah. It's actually pouring almost freezing rain right now, and 40 degrees and cloudy.
Okay, fine.
So I will take your advice, but tomorrow.
Well, then I think I'm gonna change that pick then and say you should go find your local lab or university and go on a tour because you need more science in your life. And just a week ago, or last weekend, I went to the Berkeley National Lab, went up the hill and learned about some of the most amazing science that is not even in magazines right now because it's just so new and it will completely blow your mind. And there are these grad students who are itching to talk to real human beings again instead of just their samples. Do yourself a favor, go out, meet like really cool people. If you don't have a national lab, just find your local university or something. You will learn something awesome, I promise.
Now you just made me jealous of your weather.
Yeah, dude, I miss San Francisco now more than I already did.
Well, you should just come out and yeah, you're welcome to come to the NPM office anytime in Oakland. Oakland's even sunnier than San Francisco. San Francisco's covered in fog.
Will we get spray painted if we go to Oakland now?
No, you won't.
Oh.
You won't. Instead, I will take you to Chinatown and you can get like the most delicious Chinese and Vietnamese and Japanese and Korean food you've ever had in your life. And it'll be really cheap. And unlike the rest of California, it won't necessarily be organic and grain-fed or whatever, but it'll be delicious.
That's the important part. That's all I really
think so
care
too.
about.
That's my opinion. But anyway.
Very nice. Well, thank you for coming. It's been really cool to talk about, and I'm excited to see what people wind up doing. So if you wind up doing a project, this inspires you at all, let us know. And,
definitely. And
how should they tweet at you if they do something like that?
I am Rockbot, ROCKBOT, on Twitter. That's the easiest thing. And then you can always find me. I have a blog, website, whatever, at either raquelvelez.com or a simpler link is Rockbot without the vowels, so rookbot.me.
It's Missy Elliott lyrics.
Yeah, there you go.
Yeah, we had a hack night last night, and there was a guy that was trying to turn rabbits into frogs. So
nice.
Anyway, that's just what it made me think of the workbook. Anyway,
like ribbit, I get it. I got it finally.
All right, well, we'll wrap up the show. We'll talk to y'all later. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more. Do you wish you could be part of the discussion on JavaScript Jabber? Do you have a burning question for one of our guests? Now you can join the action at our membership forum. You can sign up at javascriptjabber.com/jabber, and there you can join discussions with the regular panelists and our guests.